In this session, we're going to take a look at polynomials. Our previous session, we introduced monomials. Here we're going to take a look at polynomials. Generally speaking, a polynomial is an expression, a mathematical expression, that is showing the addition or the subtraction of two or more monomials. So let's take a look at a few examples here. We have x to the fourth plus 17. In this phrase here, we have two terms. We have x to the fourth, that's our first term, and we have 17, which is our second term. Is x to the fourth a monomial? Well, yes, it is. Remember, a monomial has to be in the form of a times x to the power of n, some power. Well, here's x, a variable, to some power, to some exponent of 4. Well, what's our coefficient, or our a? Well, it's just simply a 1, because remember, a 1 times anything, 1 times x to the fourth is just x to the fourth. So whether or not we write the 1, it is still there, and it is acting as our coefficient. Therefore, x to the fourth is a monomial. Our second term, 17, is also a monomial, because as you remember, we can also write 17 as 17 times x to the 0. And remember, x to the 0 is simply 1, and any number times 1 is that number itself. X to the fourth plus 17 then is an example of a polynomial that is made up of two monomials being added together. Let's take a look at another example here. 2x to the third minus 7x squared plus x and then minus 1. You can see that this phrase here is composed of four terms. 2x to the third is the first term, 7x to the second is the second term, x is the third term, and 1 is the last term. And you can either think of the last term as being a 1, or you can think of yourself subtracting of 1. I'm kind of using those interchangeably right now. But this is a polynomial of four terms. 2x to the third, is that a monomial? Yes, it is. 2 is your coefficient, x is your variable, 3 is your n, your degree. You also have here, if you want to think of it as a minus 7 is your coefficient, x to the degree of 2. Your third term is x with a coefficient of 1 to the degree of 1. Remember, x to the first is just the same thing as x. And then lastly here, our minus 1 can be thought of as minus 1 times x to the 0, x to the 0 being 1, 1 times minus 1 being a minus 1. So each of these terms is in fact a monomial. And this polynomial then is a polynomial with four terms. Now when we mention the degree of the polynomial, we are asking for the monomial within it that has the biggest degree. And whatever that monomial is, then that becomes the degree of the entire polynomial itself. Four terms here in this polynomial. The last term here, minus 1, has a degree of 0. Remember, x to the 0 is 1. Here we have x to the degree of 1. X to the first is the same thing as x. Here we have a minus 7x squared, the degree is 2, and in our first term we have 2x to the third with a degree of 3. So what then is the degree of this entire polynomial? The entire polynomial has a degree of 3. Because that's the monomial, that's the term that has the biggest degree to it. Over here in our first example, x to the fourth plus 17. What is the degree of this polynomial? The degree of the entire polynomial is that of the monomial that has the biggest degree within it. This has a degree of 4, and that's bigger than a degree of 0. So we have a polynomial to the fourth degree here. A couple more quick examples of polynomials. We have 1/2 y to the fourth. Well, at first sight there, let me rewrite that 2 here as I continue to speak here. At first sight, this looks simply just like a monomial. You have a constant a, your coefficient of 1/2. You have a variable, and then it's raised to some power. In this case, 4. So the degree of this monomial is 4. But by our definitions, monomials are actually just special types of polynomials. So then every monomial is in fact a polynomial. So 1/2 y to the fourth in and of itself is also a polynomial as well as a monomial. Up here in our first examples, we had two or more terms, monomials, being added or subtracted together. So don't let that confuse you. And then lastly, let's say we have the number minus 11. Question here is minus 11 a polynomial? Well, let's come back here to our first example preceding it. 1/2 y to the fourth. Is 1/2 y to the fourth a polynomial? Yes, it is, but it's a special type of polynomial called what? It's called a monomial. So all monomials are polynomials by definition. Well, the question here is minus 11 a polynomial? Well, the first question you need to ask yourself, is minus 11 a monomial? If it is, then it's automatically a polynomial. Is minus 11 a monomial? Yes, it is, because it can also be rewritten as minus 11 times x to the 0, x to the 0 being 1, and 1 times minus 11 being minus 11. So each of these different examples here are all different types of polynomials, with the last two also being monomials as well. Let's go ahead and take a look at a problem here. Okay, here is a problem written out that is a very long polynomial made up of 8 terms. Each one of these terms is in fact a monomial. So then, if you remember from our previous session, monomials can only be added or subtracted with each other only if they have the same degree. So can I take x to the fifth and subtract 4x to the second from it? No, because the degree of minus 4x to the second is 2, and my degree over here of x to the fifth is 5. We cannot add or subtract monomials that have different degrees to it. So let's start once again here at the far left. X to the fifth. Are there any other terms in this monomial that also have an x to the fifth? Well, yes, down here. We have 2x to the fifth. So let's combine those together first. Remember, when all we have here is an addition problem or subtraction problem, actually an addition problem, and remember you can think of subtraction as adding the opposite of. It doesn't matter which order we add these in by our commutative property of addition. So let's start with our x to the fifth and 2x to the fifth. X to the fifth is the same thing as 1x to the fifth. So then, what is 1x to the fifth plus 2x to the fifth? Well, that would be 3x to the fifth. So that takes care of that term and that term. Well, let's drop down 1 degree, x to the fourth. Are any terms here have an x to the fourth in them? No, they don't. So let's drop down 1 more degree. Let's go down to x to the third now, to our third degree. Are there any terms here that have an x with a third degree? Yes, we do. We have this one here. It's a minus x to the third, or plus a minus x to the third, whichever way you want to think of it. So that takes care of that term. Let's drop down another degree. Let's take a look at our x to the seconds. Do we have any terms that are x to the second? We have 2. We have this minus 4x squared here, and we have this positive 1x squared here. What is minus 4x squared plus a 1x squared? Well, that's going to be a minus 3x squared. That then takes care of that term and that term. Let's drop down 1 more degree. 1 below 2 would be 1. Do we have any terms here that have x to the first? Actually, we do. Even though x to the first was not written there, remember, x to the first is just the same thing as x. So whether or not that 1 exponent is written there, it is in fact still there. With that said, how many terms do we have with just an x to the first? We just have 1 term that way. So we're just going to add that 1 term plus x. Now we have 2 terms left, a positive 3 and a negative 1. What is the degree of both of these? The degree of both of these is x to the 0, meaning a 0 degree. Therefore, since these are both of the same degree, we can combine them together. What is plus 3 minus 1? It's plus 2. So we took this polynomial, and that takes care of our last 2 terms there. We took this 8-term polynomial, found the like degrees, found out the monomials that had the same degree to it, and then added and subtracted those together, and we were now able to write this in simplified form. This 8 8-character or 8-term polynomial can now be simplified into this 5-term. 3x to the 5th minus x to the 3rd minus 3x squared plus x plus 2. Lastly then, as a quick review, polynomials are mathematical expressions that show the addition of or subtraction of 2 or more monomials. Additionally though, all monomials are also polynomials. They're just a special type of polynomial. And lastly, the degree of the polynomial is determined by the monomial within it that has the highest degree. Each monomial within a polynomial is called a term of the polynomial. That wraps up then session 58 on polynomials.